Have you ever wondered what powers the sun? Or what element makes up most of the universe? Or perhaps, what might help us build a cleaner energy future? The answer to all of these questions is the same: hydrogen. It is the smallest element in existence, just one proton and one electron. And yet it might play one of the biggest roles in the future of energy. Hydrogen is the very first element in the periodic table. Atomic number 1. That means it has only one proton in its nucleus and one electron orbiting around it. It is the lightest element in the universe. In fact, about 75% of the visible universe is made of hydrogen. Stars, including our sun, are mainly giant spheres of hydrogen gas. Inside them, hydrogen atoms fuse together in nuclear reactions, releasing enormous amounts of energy. But here on Earth, things are a little different. Hydrogen is extremely reactive. It rarely exists alone. Instead, it bonds with other elements. For example, water, H2O, is made of hydrogen and oxygen. Natural gas contains hydrogen bonded with carbon. Almost all organic molecules contain hydrogen. So even though hydrogen is everywhere, we almost never find it freely floating around. And that leads to an important question. If hydrogen is so common, why are we suddenly talking about it so much today? Today, the world faces a major challenge. Most of our energy comes from fossil fuels, coal, oil, and natural gas. When we burn them, they release carbon dioxide, which contributes to climate change. We are rapidly expanding renewable energy like solar and wind, but renewable energy has a problem. The sun doesn't always shine, and the wind doesn't always blow. That means we need a way to store energy, sometimes for hours, sometimes for days, maybe even months. And this is where hydrogen enters the picture. Hydrogen is not an energy source like coal or sunlight. It is something different. Hydrogen is an energy carrier. That means we must produce it first, but once we do, we can store and use its energy in many ways. First, transportation. Hydrogen can power vehicles using fuel cells. Inside a fuel cell, hydrogen reacts with oxygen from the air. The result, electricity and water. No carbon dioxide, no harmful exhaust gases, only water vapor. Second, industry. Heavy industries are very difficult to electrify. Steel production, for example, traditionally uses coal, but hydrogen can replace coal in certain processes, dramatically reducing emissions. Third, energy storage. Imagine this. On a sunny day, solar panels produce more electricity than we need. Instead of wasting it, we use that electricity to split water into hydrogen and oxygen. We store the hydrogen. Later, when energy demand rises, we convert it back into electricity. In this way, hydrogen acts like a giant battery, but on a much larger scale. Finally, clean combustion. Hydrogen can also be burned directly. When it burns, it produces water instead of carbon dioxide. And interestingly, hydrogen contains more energy per kilogram than any other fuel. But, and this is important, hydrogen is only as clean as the way we produce it. There are several ways to produce hydrogen. Scientists and policymakers often use colors to describe different production methods. These colors don't describe the hydrogen itself. Hydrogen is always colorless. They describe how it was produced. Gray hydrogen is the most common today. It's produced using steam methane reforming. In this process, natural gas reacts with high temperature steam. It's cheap, but it generates significant CO2 emissions. Blue hydrogen is the bridge. The process is the same as gray hydrogen, but the carbon dioxide is captured and stored underground. In theory, this reduces emissions significantly. Green hydrogen is the gold standard. It's produced using an electrolyzer to split water using renewable energy like solar or wind. This makes it nearly carbon-free and is one of the most promising options for a sustainable future. Pink hydrogen also uses electrolysis, but the electricity comes from nuclear power. This provides a stable, large-scale, low-carbon source of production. Then there is white hydrogen. This is different. It isn't manufactured, it occurs naturally underground. Some scientists believe there are huge natural reservoirs in the Earth's crust. If we can tap into them, it could be a game changer. Beyond these, other methods like biomass gasification and methane pyrolysis are also emerging. It shows just how active this field of research has become. Hydrogen is the simplest element in the universe, just one proton, one electron. Yet, building a hydrogen-based energy system is incredibly complex. Hydrogen is not a magic solution. It requires energy to produce, infrastructure to transport, and there are efficiency losses at every step. But hydrogen also offers something unique. It can store renewable energy, decarbonize heavy industry, and power global transport. Most likely, the future energy system will not rely on just one solution. It will be a combination of renewables, batteries, and hydrogen. It may not solve everything, but it could become one of the pillars of a sustainable planet. The smallest atom, with one of the biggest responsibilities. Hydrogen has no color, but the way we produce it changes everything.